In this algebra video, I'm going to show you how to use the discriminant to determine the nature of solutions of a quadratic equation. Now, when I say the nature of the solutions, I mean we're going to use the discriminant to tell us how many solutions does a quadratic have. Are those solutions real? Are they imaginary? If they're real, are they rational or irrational? So the discriminant can tell us all of these things. So first, I'm going to show you how to calculate the discriminant, and then I'll show you how to use that discriminant to be able to determine some things about the solution of the quadratic. So let's get into it. First of all, over here on the upper left side, I have the quadratic equation. Now, in the quadratic equation, the part that I have highlighted, the part that's under the square root sign, that is your discriminant, all right? So that's the part that we're going to be calculating today that's going to give us some really important information. Now, it's important that before we try to calculate the discriminant, we make sure that our quadratic equation is written in standard form, which is highlighted in green down below. So once it's written in standard form, it's set equal to 0, then I can identify what the A, B, and C variables stand for so that I can substitute them into this expression under the square root sign and find out what the discriminant is. So let's go ahead and get into some examples. Number one, 10x squared plus 9 equals x. That is not in standard form. If we look again at the bottom left here, this equation is set equal to 0 and the one I have is not. So we're going to set this equation equal to 0 by subtracting x from both sides. So I'm going to rewrite this as 10x squared minus x plus 9 equals 0. So I subtracted that x value from both sides so that my quadratic is now in standard form. Because it's in standard form now, I can more easily identify what's A, what's B, and what's C. So in that quadratic equation in my bottom left again, I notice that A is always the coefficient of x squared. So the coefficient of x squared in number one is 10. So my A value is 10. The B value is the coefficient of x. So in my example, the coefficient of x, well, there's only a minus sign in front of that x. That's the same thing as having a -1 being multiplied by the x. So my B is -1. The C value is always the constant value. And so that for me is going to be the positive 9. Now that I've identified what my A, B, and C are, I can take them and substitute them into this discriminant that I have highlighted over there. So B squared minus 4AC. Let's substitute into that. So instead of writing B squared, I'm going to take this B value here. So it's -1 squared minus 4 times A, which is 10 for me, times C, which is 9 for me. And now we're just going to evaluate this. So I have -1 squared, which is +1, minus 4 times 10 times 9, which is 360. So I have 1 minus 360. So the discriminant here is -359. All right, that is the discriminant for number one. In a couple of minutes, I'm going to show you what that discriminant tells me about this quadratic equation. But we're going to go through a couple more practice problems of just finding the discriminant first. All right. So if you feel like you're good at it, you can go ahead and skip over about a minute or two. Number two is also not in standard form. It's not set equal to 0. So to get it equal to 0, I'm going to move those terms that are on the right over to the left. So I'm going to subtract 6a from both sides, and I'm going to add 3 to both sides, and then I can set it equal to 0. All right. Now I can identify my A value is 3, my B value is -6, and my C value is 3. Once I have my A, B, and C identified, I can substitute them into that little formula, B squared minus 4AC. So substituting in, instead of writing B squared, I'm going to write -6 squared minus 4 times, now instead of writing A, my A value here is 3, and instead of writing C, I'm going to substitute it with my C value here, which is also 3. -6 squared is +36. -4 times 3 times 3 is -36. And 36 minus 36 is 0. So the discriminant for example number 2 is 0. And again, in just a minute, I'm going to show you what that tells me about this particular quadratic. All right, in the last example, I'm going to move a little more quickly now. This one already is in standard form. We see that it's set equal to 0. So I can go ahead and identify my A, B, and C without manipulating the equation. My A is 1 because there's an invisible 1 in front of that B squared. My b is -4. It's the coefficient of the x term, or the b term in this case, the term that's linear, that doesn't have an exponent. And then the c is always the constant, so it is -12. And now I substitute into b squared minus 4ac so that I can get the value of my discriminant. B is -4, so I'm substituting -4 squared minus 4 times, my a value is 1, so I'm substituting that a with 1. My c value is -12, so I'm substituting the c with -12. -4 squared is 16. -4 times -12 is +48, times 1 is still just +48. Lastly, I have 48 plus 16, and that's going to give me 64. So 64 is the discriminant for number 3. All right, now let's talk about what the discriminant that we just practiced finding is able to tell us about the solutions of these quadratics that we're dealing with. So if the discriminant is 0, what that tells us is that there is one real solution. So that if I graph that quadratic, there is going to be one x-intercept. There'll be one point on the x-axis, which will obviously also be the vertex of that parabola, all right? If d is less than 0, so the discriminant is a negative number, think about what that means. If the discriminant is negative, that means that there's a number under the square root sign that's negative. And if we try to take the square root of a negative number, what kind of numbers do we end up with? Imaginary. So there are no real solutions. There are 2 imaginary solutions. So if your discriminant is less than 0, there are going to be 2 imaginary solutions to your quadratic. If d is greater than 0, or a positive number, there will be 2 real solutions to your quadratic. But we can dive a little deeper into the types of real solutions that there are. So if that discriminant is not only a positive number, but it's a perfect square, so numbers like 9, 16, 25, 49, if it's a perfect square, we know something more. We know that not only is it real, 2 real solutions, but we also know that they are rational solutions. Okay, so it's going to be a number that can be written as a ratio of 2 integers, or a decimal that terminates or repeats. However, if that discriminant is positive, but it's not a perfect square, 10, 11, 20, then while the solutions will be real, they're going to be irrational. Okay, so this is your little key. Let's use it to determine some things about these examples below. So number 1, given that quadratic, we did the work down below. So when we did the work for it here, we found that the discriminant here was -359. So now if we look at our key up above, knowing that the discriminant was a negative number, what we know about this quadratic is that it's not going to have any real solutions. This is going to have 2 imaginary solutions. All right. Number 2, when we did the work down here, we found that our discriminant was 0. So if the discriminant was 0, let's look at our key again. What does that tell us? That tells us that there is going to be 1 real solution for this quadratic. And lastly, we had b squared minus 4b minus 12. After doing the work, we got a discriminant of 64. And so if d was 64, 64 is positive. So according to our notes, we know that there are going to be 2 real solutions, but 64 is also a perfect square, right? The square root of 64 is 8. So because it's a perfect square, not only do we know there's 2 real solutions, but we know that there are 2 real rational solutions for this quadratic equation. All right, so this is how you use the discriminant to figure out the nature of the solutions of a quadratic.